Assalamualaikum. And in today's presentation, our group will be talking about propane, which is from the alkaline family group, which has a carbon-carbon double bond on its structure. And in our today's presentation, we'll be talking about the structure of propane, the molecular structure, physical, chemical, and properties, synthesis and resource, reaction of propane, application of propane, environmental and health impact of propane, and that's about it. So, without further ado, let's get into it. Hello, my name is Muhammad Iskandar bin Ramzi, metric number 20258665084. You can call me Iskandar.
Hi, my name is Muhammad Iman Hafiz bin Azmi and my matrix code is 2025863482 and you can call me Iman.
Hello, my name is Muhammad Afiq Azam bin Muhammad Rashidi. My metric number is 2025864602 and you can call me Afiq.
Assalamualaikum warahmatullahi wabarakatuh and hello. My name is Muhammad Adam Daniel bin Muhammad Hanafi. My matrix number is 2025800084. You can call me Dani.
So, what is propane? Propane is an organic compound that belongs to the alkane, like I said, and it has a formula of C3H6, second simple alkane. The IUPAC name the compound is propane, and it is also commonly known as propylene. Due to the presence of carbon-carbon double bonds, propane is more reactive than alkane, like I said. Especially addition reaction, propane is an important industrial chemical that is widely used as a raw material in production of plastic and other useful chemicals. Alright, so let's get to the first topic.
So now, I'm going to talk about the structure of propane. Propane has the molecular formula C3H6 and a structural formula of CH2, double bond CH3. It consists of 3 carbon atoms with a carbon-carbon double bond between the first and second carbon atoms, while the third carbon is connected by a single bond. The carbon atoms involved in the double bond have a trigonal planar shape with a bond angles of about 120 degrees. This double bond is made up of one sigma bond and one pi bond, where the pi bond is weaker and more reactive. As a result, propane is more chemically reactive than alkane and readily undergoes addition reactions. Next, this is the example of molecular structure for propane. For the structure formula, that contains 3 carbon and 6 hydrogen. For the molecular formula, it is C3H6. Alright.
Okay, now we can enter to physical and chemical properties of propane. Propane is a colorless gas with a faint petroleum smell and it is insoluble in water. It has a low boiling point and is highly flammable. The carbon-carbon double bonds make propane more reactive than alkanes, allowing it to undergo addition reaction such as hydrogenation and halogenation. These properties make it an important compound in industry.
So, we are continuing to the synthesis or source of propane. Propane is mainly produced in the chemical industry through the cracking of petroleum hydrocarbon at high temperature. It can also be obtained by dehydrogenation of propane, where a hydrogen atom is removed to form the double bond to the double bond. Additionally, propane occurs naturally in small amount in the ripening of some fruit. Its industrial production make it an important raw material for plastic and other chemicals. Next. This is example for source of propane. It contains to 48% of steam crackers, 40% of refineries, and 12% of purpose.
Alright, let's talk about the reaction of propane. So, propane undergoes a several important chemical reaction due to the presence of carbon double bond. It reacts with oxygen to produce carbon dioxide and water, which is known as the combustion process. It also undergoes a hydrogenation process where hydrogen is added across the double bond to form propane. In addition, propane reacts with bromine as well. It's called the bromine addition, which is commonly used to test and identify the alkane because the bromine solution change colors. This is the reaction, the three different reactions of propane that you can see here. Alright, we have the oxygen addition, and then we got the production of product class that produce carbon dioxide, alkane, and dihaloalkane. Sorry. Alright.
Next, we are continue to the application of propane. Propane is widely used in industry as a raw material for the production of many important products. One of its main use is in the manufacture of polypropylene, which is used to make plastic containers, packaging material, and medical equipment. Propane is also used to produce other chemicals such as propanol and acetone. Due to its wide range of application, propane play an important role in everyday life and industrial processes. Next slide. There is some example for application of propane. There are textiles, scaffold and biomedical, composite, nanomembrane for filtration, and non-woven.
Alright, now we can enter to environmental and health impact of propane. Propane is a highly flammable gas and can pose a fire hazard if it is not handled properly. In high concentration, it may cause dizziness or breathing discomfort, although it is generally considered to have low toxicity. The large-scale use of propane in plastic production can contribute to environmental pollution, especially through plastic waste. Therefore, proper safety measure and waste management are important to reduce its environmental and health impact.
So, lastly, the conclusion. In conclusion, propane is an important organic compound from the alkene family due to the presence of a carbon-carbon double bond, which gives it high chemical reactivity. The structure and properties allow it to undergo various reactions and make it useful in many industrial applications, especially in the production of plastics and other chemicals. Despite its benefits, propane must be handled carefully because of its flammability and environmental impact. Overall, propane plays a significant role in modern industry and everyday life. Alright, that's the end of our presentation. Thank you for staying and goodbye. Let's get back to the outro.